Today, as part of his treatment, Martin will have a PET scan. This is an extremely advanced diagnostic examination that uses minute quantities of short-lived radioactive compounds. In the film, we see what PET is and the race against the clock to make sure that Martin gets a PET scan in time. Roel is the cyclotron operator. It's his task to make sure that sufficient radioactivity will be produced in the cyclotron within the next 3 hours. The radioactivity will then be incorporated into the radioactive compound with which Martin will be injected for his PET scan. A number of different compounds can be produced, but for Martin's examination, Roel is preparing the radioactive isotope fluorine-18. Radioactive material is made in a cyclotron. Hydrogen ions are generated in the center of the machine. A changing electrical field accelerates these ions. The speed of the hydrogen ions is increased by a perpendicular magnetic field which ensures circular movement. When the velocity is high enough, the hydrogen ions are deflected outwards and directed onto special water enriched with oxygen-18. The hydrogen ion reacts with the oxygen nucleus, producing unstable fluorine-18. To return to a stable condition, this atom emits a positive electron. For Martin's examination, fluorine-18 is used, which has a 2-hour half-life. This means that within 2 hours, the amount of radioactivity decreases by a factor of 2, so everything has to be done quickly. In this laboratory, compounds are labeled with the radioactivity produced in the cyclotron. Heavy lead shields are used to protect staff from radiation. The laboratory is also thoroughly ventilated. Because the radioactive compounds are injected into patients, production conditions and methods are subject to extremely strict regulations. The entire package of provisions and measures is called GMP, Good Manufacturing Practice. FDG, an analog of sugar, is used in Martin's examination. Monique now has to label the FDG with the radioactive fluorine-18 isotope. Most of this can be done using an automatic process so that Monique is exposed to as little radiation as possible. In this process, an oxygen atom in the glucose molecule is replaced by a fluorine-18 atom. The glucose molecule becomes radioactive and emits a positive electron. The chemical part is over. The FDG is pumped into the cleanest area of the lab, where sterile vials are filled for distribution. One of the vials contains the FDG for the PET center. Another one goes to the analysis lab for extensive quality control. 3 months ago, Martin was found to have a malignant lung tumor. Small lymph node metastases were also detected. Martin has undergone chemotherapy. Now he is on his way to the PET center where he will have a PET scan. The scan will show whether or not the chemotherapy has been effective in eliminating the metastases and thus whether the tumor can be removed by surgery. First, Martin reports to the secretary who registers his data. To limit radiation exposure, the FDG is packed in a lead container, which is kept in a large box. The empty space around the container is a further safety measure. The level of radioactivity emitted from the packaged FDG is measured to check that it is suitable for transportation. The FDG is now ready for transportation. FDG is also delivered to other PET centers as far away as Belgium. Part is taken by transport cart underground to the PET center of the VU University Medical Center. A fax from the pharmacist arrives at the hospital. The FDG meets the requirements and is released. The research technician fills a syringe with sufficient FDG for Martin. To keep radiation to a minimum, the syringe is taken to Martin in a lead case.
Het is de bedoeling dat we straks weer een infusie gaan inbrengen. In dat infusie injecteren we een radioactief suiker. Dan is de bedoeling dat u een uur op dit bed komt te liggen. En dan waarvan u het eerste half uur niet mag praten, niet mag lezen.
Ja.
En dat na het uur inwerken gaan we foto's maken.
Begrijp.
Ja. Hallo,
Goedemorgen.
Judith Herder.
Martin Meester.
Martin is injected with the radioactive FDG. He must wait for 1 hour before the FDG has spread throughout his body via his bloodstream. Other radioactive compounds are also used for diagnostic and research applications. Before a compound can be used, it is subjected to extensive research. In the Radionuclide Center, a GMP hot lab complex has been built specifically for this purpose. The most advanced PET camera has also been installed here for experimental research. In the future, the camera will also be used for neurological examinations in patients. A small cyclotron specifically for producing radioactive oxygen with a half-life of 2 minutes has been installed in the hospital. The radioactive oxygen needs to be used so quickly that even the distance from the Radionuclide Center to the PET Center is too large.
We gaan beginnen. U mag meekomen. Ja, komt u maar. We nemen de spullen mee. De jas. En deze jas. Verder heeft u niks? Nee, komt u maar. De jas hang ik daarop. Mag u even de zakken leegmaken, de broekriem af. Goed. En alle munten en sleutels uit uw zak.
Kan ik dat hier neerleggen?
Ja, mag u rustig. Mag u op het bed komen liggen?
Martin has a whole body scan. His entire body is searched for metastases. The radioactive FDG is taken up by tissues that use sugar. Because most tumors use more sugar than surrounding normal tissue, they can be visualized easily with a PET scan.
Doe er een band omheen.
Ja.
Ook vanwege steun. Gaat u nu in? Mag u even de ogen dicht doen?
A PET isotope such as fluorine-18 emits a positron. A positron is not stable in tissue. Before it has traveled 1 millimeter, it will combine with an electron. These particles are converted into energy in the form of gamma rays. Detectors register the gamma rays that are emitted, and the information is sent to a computer. A PET scanner has many tens of thousands of these detectors. By combining these signals, the distribution of the gamma rays, and with this, the distribution of FDG, can be reconstructed. Because Martin has a whole body scan to see whether the tumor has metastasized, his entire body is examined bit by bit. Only an area of 15 centimeters can be scanned at a time. When one area has been scanned, the bed slides down another 15 centimeters for the next scan. Martin's scan is finished. He can go home. The results of his PET scan are analyzed by the nuclear medicine physician.
Ja, dat is gunstig. Dat betekent dat er geen lymfkliermetastase meer zichtbaar zijn in het mediastinum. En dus kan de patiënt vermoedelijk geopereerd worden.
This film shows just one important application of PET. The technique is not only used in oncology, but also in neurology, psychiatry, and cardiology. The VU University Medical Center, the Radionuclide Center, and the BV cyclotron together form a unique combination for the clinical and scientific application of PET. The PET facilities and activities are unique in Europe, providing tremendous potential.